All right, today we're going to go through derivatives part D. We're not going to go through E just yet, but I wanted to talk about trig derivatives. And I'm not going to go into about this. You'll go into much more detail next year in calculus class, but I wanted to introduce the concept and introduce some of the functions that you'll be seeing. But we're not going to do a lot of the long proofs that we have here. But I just wanted you to see them. So we're going to look at trigonometric derivatives. Conditions in which trig derivatives apply? Well, only functions containing trig functions use this technique. And what is the formula? Well, there isn't one set formula. We kind of have to prove each one individually. And like I said, we're not going to go through any long proofs today that you have to memorize or understand necessarily. So let's take a look at this trig function. Proof of f prime of x when f of x equals sine of x. So what is the derivative of f of x when it equals sine of x? Well, we're going to go back to the definition of a derivative. When we're going to take the limit, remember, as this h approaches 0. Again, I'm not going to go through every step here, but I just wanted to show you that to prove a trigonometric derivative, we have to go back to the definition. And we can't apply any of those fancy rules that we learned in the last couple of classes. We just have to do it the long way. And if I do it the long way, again, I'm not going to go through all this, but we'll figure out that the derivative of f of x when f of x equals sine of x equals simply cosine of x. So with this whole long proof is going to show that the derivative of sine of x is cosine. Well, not all the trig functions are quite that nice when they finish, right? Sine of x prime is equal to cosine of x. So we know that, but they're not all this nice and neat. Cosine of x, the derivative of that, turns out to be negative sine of x. And we could go through a long proof if we wanted to. Tangent, well, we would have to use the quotient rule for sine of x and cosine of x. And using u and u prime, v and v prime, well, we could use the quotient rule to come up with this, secant squared of x. And we could go through all the trig functions just like that, proving some of these things. Cosecant is 1 over sine. Well, then we could use the quotient rule to figure out that the derivative of cosecant of x turns out to be negative cosecant x cotangent x, whatever that really means. So here are the list of 6 trig functions and their derivatives, okay? And we could prove all those if we really wanted to, but we're not going to do that. But this is just a reference for you to keep handy, right? Next year in calc, you'll go into a lot more detail about these things. All right. So how can we use these then? Well, if we have one like this, f of x equals x sine of x, well, using our product rule, u is equal to x, v is equal to sine of x, u prime is equal to 1, v prime, we saw that the derivative of sine was cosine. Well, and we've used the product rule to show that it's equal to sine x plus x cosine x. So it's a lot of work to keep these things all straight, and it's worth the time to make sure that you don't rush and you don't make mistakes on this. Here, f of x equals x squared divided by cosine of x. What's the derivative of that? Well, we could use the quotient rule and come up with this, right? So I'm not going to go into a lot of detail, but I did want to go over the in-class worksheet, and we're going to do that next, okay?